Welcome all. Today we are just going to see about the types of agent. So already we have been discussed about agent, rationality and other types of agents. So rational agents. And now we are just going to see about the basic six types of agent that in order. So let list out one by one. Table driven agent, simple reflex agent, model based reflex agent, goal based agent, utility based agent, learning agent. So, to tell about the basic about it, table driven agent. Driven agent, it is stored all possible percept sequences and corresponding action in a lookup table. It simply checks the table and performs the action specified. How it is working. So it receives the percept, searching the lookup table, and whatever the stored information that can be executed in an action. Next will be of simple reflex agent. Simple reflex agent selects the action based only on the current percept. It ignores all the past information or past in history of it. So that is about the simple reflex agent. Model based reflex agent. So it is also one type of an agent. It is mainly maintains an internal model of the world. It remembers previous states and updates its knowledge. So that is about the model based agent. Next is goal based agent. Goal based agent chooses action that help to achieve the goal. Instead of blindly following the each and every rules, it evaluates the future possibilities. That is about the goal based agent. Next is utility based agent. Utility based agent selects the action that produces the highest utility based on the satisfaction. It does not just achieve the goals, it tries to achieve them in the best possible way, where the function will be of agent. Next is learning agent. A learning agent improve its performance through experience, and it is also learns from the success as well as the failure. Let me see one by one in the next slides. First is table driven agent. So table driven agent is the simplest type of agent. So it uses a predefined lookup table that contains all the possible percept sequences and correct and corresponding actions to it. Whenever the agent receives a percept, it searches the table and performs the action stored in the table. So the basic idea about the table driven agent is percept sequence will be follow the lookup table and whatever the action that is going to follow up. The agent does not think, reason, plan or learn. It simply looks up what the answer from the table. So now how the table driven agent works. So receive the percept. It will be often first step. So whenever the location A status will be of dirty, so we can take it as a good example of vacuum tube cleaner. The next step is searching the table. The agent searches for the matching entry. If it is of dirty, it sucks. If it is of clean, it will be moves either left or right. And next is dirty. If it is sucks, it will be clean, move or left or right. Execution is a third step that matching action will be of suck. So the working will be of sensor reads that will be of either A or B, that can be of suck. Table lookup will be stored in the suck, that is of A dirty. Action will be of suck. Result will be room A becomes clean. So percept sequence concept. A table driven agent stores not only the current percept but sometimes the entire percept history. So that is only the become the main concept of it. Why the table size becomes huge? So there are two percept concepts will be using in the table driven agent. One is of dirty, one is of clean. So two possible entries will be there. Suppose if there are 10 percepts are there, so we'll be assume 2 power 10, that is 1024 numbers we are just going to check the condition for it. So possible combination will be of 2 power 100. It is an enormous number, therefore the table becomes impractical to determine whether it can be occurred with the lockable table or not. So next is coming to the listed below from the each and every drawbacks, size of the table. So as a problem complexity increases, the table size also increases exponentially. The good example for the size of the table is an chess playing agent. Whenever we are just going to play a chess, so there are board positions will be there, millions, and board moves will be of thousands. The table must store each and every board state plus each and every action. So it is impossible to store each and every result of it, and there will be of the memory requirement, it requires of huge time of bond. Next is time to build the table. So before the agent can work, the entire table must be prepared. The good example for this, a self-driving car. The table must include the traffic situation, road condition, pedestrians, weather prediction or weather climate, signals, and other obstacles. There are thousands of combination of obstacles are there. So creating such a table, it takes might be a month, or it takes might be a 6 months, or it takes might years. So very huge and high development time, that will be the results which can be predicted with the time to bound table. Next will be of no autonomy. So the agent cannot make a new decision on it. Everything is already stored. Suppose a traffic signal appears with new, there is of new sign. If it is not in the table, no matching entry will be found over there. So the automatically the agent fails. So there will be of no flexibility and no independent thinking of the particular agent. And last will be of the time required for learning. So even if the agent learns, the learned knowledge must be added to the table. So a good example, we can take it as a robo. So wet floor is slippery. The information must be inserted into the table. As the environment changes, so the new knowledge will be required, new entries will be required, and it will be entered into the larger table. So the result will be of slow learning process. So we can assume the real time analogy we can prepare for it. Imagine the student preparing for an university or cycle test exams. So table driven approach that can be represent with the memorizing question 1 equal to question, that question 1 in the university papers or any question paper which can be comes for test, that will be of question 1 will be a answer for question answer 1, question 2 will be represent to answer 2, question 3 will be represent to answer 3. If a new question appears, so no memorized answer is there, the student cannot be respond. This is exactly how a table driven agent behaves. So the advantage of using of table driven agent, it will be of simple, easy to implement, fast retrieval, and useful for smaller problems. Disadvantage in sense, huge table size, huge memory usage, difficult to build, no reasoning, no autonomy, and poor scalability with a no intelligence. So this is about the table driven agent. Next we are just going to move to simple reflex agent. So simple reflex agent is one of the simplest type of intelligent agent in artificial intelligence. A simple reflex agent selects what type of action based only the current percept or current situation, and it can be ignores the history of previous percepts. So it uses only the current situation by ignoring all the history of perceptions. So it will be perform action only in a simple situation, and the environment that can be worked with fully observable. And this type of an agent function that can be represented with conditional action rule, if then, if condition then action. So that is a good example for it. So before going to that, we'll be having an example for it based on the given algorithm. So we'll be having an example for vacuum cleaner. Function reflects vacuum agent, location, comma, status, return an action. So what exactly it will be receives is that the function receives a percept and returns an action. So percept can be represent equal to a comma dirty. So then the agent stores the predefined condition action rules. So if a dirty is there, it will be sucks. If it is of clean and A tends to right. If it is of clean and B tends to left. So state equal to some status equal to some value can be represented, that can be represented with the converts the percept into meaningful state and files the rule matching the current state. So if it is of dirty the state, and then the matching rule, if the dirty is there then suck. If it is clean, automatically it will be moved to either right or left condition according to the particular scenario. So this is about the condition of an algorithm whenever we are just going to use the vacuum cleaner based on the simple coding program that can be elaborately explained with it. So that is about it. So now in the next slide, so this is the simple based agent rule. So we'll be having a different types of block diagram over here. So let me see one by one. So the first we can see about the environment. The environment in turns with the simple based agent is an external world in which the agent operate by itself. Examples: a vacuum cleaner in the room problem, and roads in a driving car, and chessboard for playing a chess playing agent. And next is sensors. Sensor collects the information from the environment. So whenever we can use the agent as human, the sensor will be used with the eyes and ears. Robo will be of camera, infrared sensors. Vacuum cleaner will be of dirt sensors. In the particular diagram, the environment which can be points with the sensor. The sensor receives the current percepts. And here, what the world is like now. This entire block represents the current percept received from the sensor. The agent only knows the present situations. Example: location equal to A, the status will be of dirty. The agent knows only this information. If it does not knows about it, what happened earlier, which room was cleaned before, and it can be predict with the previous action. Next, condition action rule. So the agent contains the set of predefined if then rules. If the condition is for true, then it can be performs the action. So if it is dirty, then it sucks. If it is of clean and it can be moved to the location A, then move right. If it is of clean and location B, then if it is of move left. So there is the rules that can be stored into an agent. So what action I should do now? This is the decision making component. The agent will be observes the current percept, matches into the rule, and it will be especially selects the corresponding action. So current percept will be of A comma dirt. Matching rule will be of if dirty then suck. Selection rule will be of suck. And what will be the effector, that is of actuator, will be play a major roles over here. Effectors or actuator executes the chosen action. Example: human will be of leading with the actuator like hand and leg. Robo will be of using with the actuator called wheels and motors. Vacuum cleaner will be of wheels and other motors. So this is how we are just going to use the particular condition for it, and actuator activates the suction motor and cleans the room effectively with the neat and everything. So the advantage of using a simple rule based agent will be of it is very simple design, fast decision making, easy implementation, and it requires less memory. Whereas here no memory, disadvantage will be of no memory, cannot learn by itself, and cannot handle the partially observable environment, cannot consider the future sequences. So real time example that can be suit with a simple rule based agent. If a person is detected, then open the door. If temperature greater than 30 degrees Celsius, then turn on AC. So this is about the simple based agent. Next is model based agent. A model based agent is a model which can be improved over the simple reflex agent because it maintains the internal state memory about its environment. Why do we need to go for model reflex agent? So the problem is with simple reflex agent. A simple reflex agent only looks only at the current perception. So current perception which tends to rule, which tends to action. It does not remember the previous situation. Consider an example, a robo moving in a building, room A, room B and room C. If the sensor cannot see the room A, after moving to room B, the robo forgets what was in the room A. So this creates a problem in between room A, room B and room C, and this is said to be as an partially observable environment. To solve this, we are just going to model based reflection agent. So now we will be seeing the diagram for it. So this is a overall diagram of model based reflex agent. So here also the same like simple reflex agent. So first is environment. The environment is the external world where the agent operates. Room A and room B, or we can take it as a road, building or traffic problem. Sensor. So sensor usually know we can be collect with the information from the environment. So it is used with the examples like human that can be sensed with eyes and ears. Robo will be of camera, IR sensors, and vacuum cleaner will be of dirt sensors. So environment can be pointed with the sensors. Sensors receives the percepts and what the world is like now. So this exactly represents the agent's current understanding of the environment. It combines the current sensor information, previous memory, and world model. So sensor stays the room B is dirty. Memory says room A is clean. Current understanding become A is clean, B is dirty. So now how the state and how the memory can be stored in it. So this is an important point. The agent stores the information about the previous situation. State will be of room A equal to clean, room B equal to unknown. After moving the state, the room A equal to clean and room B equal to dirty. Even if the sensors cannot see the room A, now the agent remembers it. Now, how the world evolves. This entire block represents the knowledge about how the world changes naturally. Example, the traffic system. So first of all, in the morning, heavy traffic will be there. According to that, by evening. So example 2 will be of vacuum cleaner. We can take it as clean in the room. People walk in, the room becomes dirty. The agent understand what are the changes that can be need to change, what my action do. So the block stores the knowledge about the effect of actions. The good example with the effect, what action to do, move right, it changes the location. Suck, removing the dirt. Open the door, door becomes the open. So this is about the example. So vacuum cleaner action will be of suck, effect will be of dirty equal to clean. So and finally we'll be using of condition action rules. So like a simple reflex agent, rules are still used. If the room is dirty, then suck. If the room clean and location A, then move right. What action I should do now? So the decision making component, the agent uses current percept, memory, world model and rules. Actuator will be of performs the action in the environment, and human will be of similar like a simple based rule agent. So this is a good example for it. So moving to the next slide. So this is the algorithm that can be represent with the explanation. So this is a agent that can be maintaining the internal state memory of the environment. So let me see the function of a model based reflex agent percept and returns an action. So here the agent receives the percept from the environment and returns the actions. We can take it as an example as a vacuum cleaner. Percept equal to room A comma dirty. So the function must decide what action to take. Next is persistent. So persistent means The value are stored in a memory and are available for the future decisions. So a state represents the agent's current understanding of the environment. We can take it as an example: room A equal to clean, room B equal to dirty. Even if the sensor cannot currently see the room A, the agent remembers it. Next is model. So it describes how the world changes naturally and how the actions affect the world. So we can take it as an example: clean the room, people enter, room becomes dirty. So the action effect that can be represented as an action equal to suck, that can be of room dirty will be becomes a clean. So the agent stores the knowledge in this model. So rules: a set of condition action rule. If it is of dirty, then it is sucks. If it is of clean and location A, then move right. If it is of clean and location equal to B, then move left. Action will be of, it stores the most recent action performed. Initially action equal to none. After moving, action equal to move right. So and next state will be of state equal to update state of state comma action comma percept comma model. So the agent updates its internal memory using the previous state, previous action, current percept and world model. So the example for its previous state, we are using of A equal to clean, B equal to unknown. Previous action will be of move right, current percept will be of B equal to dirty, and updated state will be of A equal to clean and B equal to dirty. The agent now has complete a picture of the environment and finding a matching rule. So rule, conditional rules we are using with it. So rule which can be represented with rule match of state dot state comma rules. So the updated state is compared with the stored rules. So B equal to dirty. If dirty then suck, matching rule will be of if dirty then suck. So select the action for it. Action equal to rule dot action extracts the action from the match rule. Example: rule equal to if the dirty is then sucks, action will be sucks. And finally return action. So the action will be sent to the actuator and the vacuum cleaner starts cleaning. So this is the exact thing how we are just going to flow with the each and every thing. And other one real time example that can be treated with the model based reflex agent is an, so we can take it as an exam oriented definition. So internally how the world evaluates it, and the percepts according to the exam oriented how the students are approaching each and everything based on the preparation. So that is an good example for model based agent. Next will be of goal based agent. So goal based agent is an advanced AI agent that chooses an action based on specific goal it wants to achieve. Unlike a model based reflex agent, which we are just going to simply follows the condition action rules. So whether the goal based agent thinks about the future and selects what action that help to reach the desired goal of it. So why we need to go for goal based agent? So the current state will be there and it will be of match with the rule based action will be performed according to it, and it follows the predefined rules. Suppose a robo wants to reach a room D. The rule based system may not know which the path is best to reach it. Therefore we need to achieve the goal from plan A, plan B, that is of room A, room B, room C and room D. According to the rule we are just going to make a plan, and finally we are just going to represent over to it. So let's we see the diagrammatic representation of it. A goal based agent, the similar like model based as well as the simplex based agent. The state will be of stores the current state of the world and room location. The current room will be of A. The agent remembers its current position of it. How the world evaluates. So it represents the knowledge about how the environment changes naturally. Examples we can take it as a traffic system. In the morning heavy traffic will be there, and by the evening it follows according to the changing over the time to time by morning, evening and night. So the agent knows the traffic condition changes over that time. So why do my actions do it? So stores the effect of actions. So move right. So automatically the effects will be changing the location changes of A to B. What the world is like now. So this is the current situation perceived by the sensors. So current location equal to A. The agent knows where it is currently. So what it will be like if I do action A. So this is the most important part of it. The agent predicts the future states before acting. The current state will be of location A. Possible action will be of move right, move left and stay. Predicted results will be of move right equal to B, move left that can be of invalid statement right now, stay will be of A. So the agent imagines to predict the future outcomes. And next, what is goal? The goal tells about the agent what it wants to achieve. So goal, we are just going to reach the room D, and goal will be reaching the destination or final source for it, and goal will be of an checkmate opponent while we are just going to use with the playing of chess game. So what action I do now? The agent compares predictive future states with the goal. So current will be of A, goal will be of D. So move right will be of B, move left it will be of invalid, stay in A. Best action move right because it moves closer to the goal. So and what will be the effectors that can be of an actuator? So execute the selected action. Example, action will be of move right. The robo will be move according to the scenario, and complete will be of robo wants to reach the room from A to B, B to C, C to D, and finally it is achieving the goal. Once it is detected with the sensor, the current state equal to A and move right, state equal to B and stay, state equal to A, and comparing with the each and every goal, reach D. From B it is closer, from A it is same, move right, and finally it will be repeated according to the scenario. A tends to B, tends to C, tends to D. The goal is achieved. The real-time example for goal-based agent is GPS navigation is good example. So from Chennai to Bangalore, we are just going to possibly we are just going to traversing with the three different types of routes. Via we are just going to pass with one area to other area, and one traveling time to another traveling time, route 1, route 2, route 3. How we are just going to predict the future outcomes and selects the route leading to the destination. And other example we can tell it as an chess playing agent. So currently the state will be of chess state will be of current position, and checkmate will be of a given option. So the agent predicts the future move A, that will be of if you are losing your queen, move B will be of automatically maximum possible moves will be of checkmate. So that is why we are just going to move B. So this is about the goal based agent. And the advantages of goal based agent is goal oriented behavior, flexible decision making, can plan for future action, and it can be solve only new problems, more intelligent than the simple reflex agents. So the disadvantage of using of goal based agent, it search process may be slow, it requires more computational time and need accurate goal information. So the example I already told about it, a GPS navigation system as the goal of reaching the destination. It evaluates the possible routes, predicts their outcomes, and selects the routes that leads to the destination more effectively. So it maintains the internal model of the environment, predicts the possible outcome action, and compares the outcome with the desired goal. And finally, it selects the action that helps to achieve the goal, that can be make a plan for reason about the future states, and it be of more flexible and intelligent with the reflex agent. So that is about the goal based agent. So now we'll be moving to the next slide. So that is often utility based agent. So utility based agent is an intelligent agent that chooses the action that provides the highest utility, so maximum satisfaction or benefit. So it is an improvement over the goal based agent. So why do we need a utility based agent? So utility based agent only checks whatever the goal achieved. yes or no. Suppose there are two routes to reach Chennai. Route A equal to 2 hours, route B equal to 5 hours. Both routes reach the goal. A goal based agent sees the goal reached, yes, but it cannot be determined which route is better. So for utility based agent evaluates the time, cost, safety, comfort, fuel and risk, that chooses the best option for it. So now we'll see the diagrammatic representation of utility based agent. So utility based agent similar like the goal based agent. So similarly we'll be having a state. So stores the current condition of the environment. So example we can take it as an current location equal to Chennai. How the world evolves. So it is used to represent how the environment changes naturally. So morning it will be of heavy traffic, night it will be of less traffic. The agent understand these the time changes occurs between the environment. So what do my actions? So it stores the knowledge about the effect of action. So action equal to take a highway, effect will be of how the travel time it has been reduced while going in a highway. So what the world is like now. So current information receives from the sensors. So current location will be of Chennai, traffic equal to moderate. What it will be like if I do the action A. So the agent predicts the future states. So the current state will be of location equal to Chennai. Possible action will be of whether you are following with the route A, route B and route C. So the predicted results will be of route A will be traversed with 3 hours, route B will be traversed with 5 hours, route C will be traversed with 4 hours. So this is more important function on component of the utility function. And utility, the numerical value representing the satisfaction. Higher utility will be of better state. So suppose if it is of taking more number of thing, so route C will be preferred the highest value and take the particular utility to reach the destination. How happy I will be in such a state. So the agent utilizes and calculates the utility of every predicted state. So route will be having of ABC and the time will be 2 hours, 3 hours and 4 hours. Fuel cost will be 500, 200 and 100. Utility will be of 80, 70 and 60. Utility generally it can be represent of how much of happiness, how much of satisfaction. Utility values indicates the satisfaction. And finally what action I should do now. Choose the action with the minimum utility. So minimum utility will be of 60, utility A will be of 80, utility B will be of 75 and utility C will be of 60. So you'll be having of 80 utility, and what the actuator does is that it executes the selected action. So take a route A. So after completing route plan, we are just going to travels, a person travels from Chennai to Bangalore, reaches the Bangalore, then these are the three routes that can be exist. So time will be of 4 hours, cost will be of rupees 500 and safety will be of high. So other route it will be of 3 hours and cost will be of 1000 rupees and safety will be of medium. And route C will be of time equal to 5 hours, cost will be of 300 and safety will be of high. So this is about the utility based agent. So how we are just going to represent it. The other example for utility based agent we can consider with the best routes already. So we can tell about the online shopping recommendation. So Amazon, Flipkart recommends the products based. So that is of VLB. Choose the product based on the price, ratings, popularity, and delivery time. Each and every product that receives the utility scores, and highest score will be of recommended, and they will be having a discount for it for each and every recommendation. So the advantages of using utility based agent, it chooses the best solution among many alternatives. It handles the uncertainty and it also supports the complex decision making, more flexible than the goal based agent. And especially it is used in the modern AI system. So the disadvantage of utility based agent, so utility calculation can be more complex, requires more computation, designing utility function may be more difficult to it. So the good example for using utility based agent, a GPS system can reach the destination through multiple routes. A utility based agent evaluates the travel time, cost, safety, and traffic condition, assigns utility value to each and every routes, and finally selects the route which is having the highest utility with the proper satisfaction and happiness. So to conclude this, so it measures the desirability or satisfaction of different states, and it is also used to predict the outcomes of possible actions, evaluates their utility values, and chooses the maximum utility that can be used with the action. So compared to the goal based agent, it not only achieves the goal, but it is also used to select the most beneficial way of achieving them with a happiness as well as satisfaction. So the last type of agent is learning agent. So learning agent is the most advanced type of AI agent. Unlike other agent, it can learn from the experience. So improve its performance over the time and adapt to changes its environment. So this is about the learning agent. So learning agent which can be represented with these are the four components: performance element, learning element, critic, problem generator. Performance element, it selects the external action, take in percepts and decides what action to be performed. Learning agent, it is responsible for making improvement by observing performance. Critic, learning elements takes the feedback from critic which describes how well the agent is doing with respect to fixed performance standard. Generating the problem, the component is responsible for suggestions, actions that will lead to new informative experiences. So let me explain with the diagram. So the performance element that will be of the performance element is responsible for selecting action. It will be acts like a brain of the agent. So environment will be passes through the sensor, performance element, and action. So we can take it as an robo vacuum detects a dirt. So room is dirty. The performance element will be go and check with it and sucks. The performance element performs the action. What is the role of critic over here? The critic evaluates how well the agent being performed. It compares actual performance with the desired performance standard. So performance standard is critic. Suppose a self-driving car chooses a route. So expected will be of travel time is 20 minutes. Actual time is traveling time of 40 minutes. The critic detects performance is poor and sends the feedback to the customer. Learning element. So improves the agent knowledge using the feedback from the critic. So critic will be of observing the feedback and learning from the element. So robo vacuum, before learning it moves randomly. After feedback, learn shortest path with the cleaning and observe it and reach the destination. The learning element updates the each and every agent about it. And what is meant by problem generator? So suggest the new actions for exploration. Without exploration, the learning becomes slow. So the problem generator will be provides the new action to it. The robo usually uses path A. The problem generator suggests try to traverse with path B. The robo may discover a better path. So observe the environment. Sensor receives the information. So the room is dirty and performance element acts. So dirty room is dirty. It will be move forward. The action executed. Critic evaluates. So performance standards that is of cleaning the room in 5 minutes, but cleaned in 8 minutes. Critic generated feedback. Learning element learns. Current strategy insufficient. Updates knowledge. Problem generator explores. It suggests try to follow the different cleaning pattern. Improved performance. Clean room in 4 minutes. Performance achieved. Improved. So initially it will be of following the thing and it will be acquiring the knowledge. And the real-time example for learning agent is Netflix recommendation. Initial recommendation, the Netflix suggests random movies. User watches the movie. That action movies, any other movies that can be represented. Learning from that system learns. User likes the action genre. Improved recommendation. So more action movies and less romance movies. Recommendation improve over time. So the advantages of using learning agent is it learns from the experience, improves the performance automatically, adapts to change the environment, handles unknown situation. And it is a more intelligent type of agent in compared to all other five different types of agent. So disadvantages will be of requires the training data, learning make over time, computationally expensive, may initially makes mistakes of it. So real world applications, Netflix will be of more recommendation, Amazon will be of product recommendation, self driving car will be of route learning, and chat gpt will be of learning from the training data, Google Maps will be of traffic predictions. The real time example that suits for learning agent will be of a spam email filters, learns from the user feedback. When user marks an email as a spam or not spam, the system updates its knowledge and improves the future classification. This continuous improvement makes the learning agent. So to summarize it, so all the four components that can be used with the learning agent to improve its performance through experiences. The four components that will be of a performance element, critic, learning element, and problem generator. The critic evaluates the performance and provides feedback. The learning element updates the knowledge, and problem generator encourages the exploration. Over time, the agent becomes more efficient and intelligent by learning from its interaction with the environment. Thank you.